So today we will be dealing about a different branch of science. So long we learnt about physics. So today we will be learning about chemistry. So as soon as you hear about the word chemistry, what comes to your mind? Take a few seconds and think about it. Yes, we think about all the boiling solvents in the laboratories where you see in the picture where there's a lot of gas coming out, things bursting, and all this only comes to your mind when you think about chemistry, the complicated equations. But chemistry is there in our day-to-day lives also, where you find very simple things in chemistry. Every day you see things around us involves chemistry, but none of us have a keen notice on it. So we will see what all is present in the natural or everyday environment has chemistry in it. The first one, you see in the picture, right? Candles burning. There's light emitted and the wax is getting melted when a candle burns. This is simple example of chemistry in everyday life. The air that we breathe in, what do we take in when we inhale? You take in oxygen, which is an element. Okay, that is also chemistry. When you breathe out, you leave out carbon dioxide. There is chemistry behind it also. The picture on the right shows food. The food that we eat also has chemistry. The process of digestion, where the stomach produces a lot of acids, like concentrated HCl is produced by the stomach to help us in digestion. There is chemistry behind that also. Consider our human body itself. See, our body is made up of lot of elements, naming nitrogen, carbon, hydrogen, and oxygen. Oxygen makes about 65% of the human body. So imagine there is chemistry in our own body itself. Our body is very complicated. It has biology, it has chemistry. So you should be thankful to God for creating us as such, human beings with complex and very intricate patterns. Okay, so be thankful to God every day for who we are and how He has made us to be. Okay, so what do you observe in the picture? There is a car moving and it emits some smoke. So, what makes the car move? Obviously, a driver is driving the car. There's something else which has to be put in the car for it to move, for it to make it to move. So there is fuel. Yes, there is fuel which has been put inside the car. It can be both diesel or petrol. It can be any one of the two. So there has to be fuel which is put inside the car to help it, move. So where does what do you see in this picture? It is coal. It is called curry in Tamil. When you burn wood, you get coal. Okay. So what makes the trains move? In earlier times, trains used coal, the burning coal, which is used as a fuel for moving the trains. So what are all these? Petrol, diesel, and coal. These are all fuels for different vehicles. So we will come to our topic. Our topic for the day is hydrocarbons. Hydrocarbons. So what are these hydrocarbons? These are organic substances. From the name itself, you can get hydrocarbons. Hydrocarbons are made up of two main elements, hydrogen for hydro and carbon for carbon. So, hydrocarbons are organic substances which has hydrogen and carbons. I repeat, hydrocarbons are organic substances which has hydrogen and carbon. See, hydrogen on the left and carbon on the right. This is the composition of hydrocarbons. So, what is the sticker? It says combustible. It has a fire or a burning symbol. So, what is the important characteristics of this hydrocarbon is that they are combustible. In simple terms, they are flammable. When you put fire, they will burn readily. Immediately, they will burn. So, that is called combustible. It is one of the important characteristics of hydrocarbons. So, what happens when these hydrocarbons burn? It needs oxygen for burning. Anything which burns, for example, take a candle. When you put a glass on top of a candle, what happens? It stops burning because there is no supply of oxygen. So for burning there has to be oxygen. So what happens when hydrocarbons burn in the presence of oxygen? They give out water vapor and carbon dioxide. And you see CO2, that is a symbol of carbon dioxide. So when hydrocarbons burn in the presence of oxygen, they give rise to carbon dioxide and water vapor. So we saw what is hydrocarbons. We'll see about the important properties of hydrocarbons. First one, solubility of water. What do you see in the picture? You see a candle burning, right? And the candle which has been burning is put on a jar containing water. What happens? The wax droplets float on water. So this shows that hydrocarbons are not soluble in water. Okay, there is also another condition. See, not all hydrocarbons are insoluble in water. It says most of the hydrocarbons are insoluble in water. So there are exceptions. Most indicates many, or most is not all. It does not include all the hydrocarbons. For examples, we already talked about petrol and diesel. So petrol and diesel are soluble in water. You can mix water. There is a scam which is going on where many of the petrol bunks, there is an increase in price of the petrol and diesel every day. So how will these petrol bunks make a lot of profit? It is because they say there are petrol bunks which mix water. So it indicates how some of the hydrocarbons can be soluble in water, like ethanol, or as I already mentioned, petrol, diesel can all be soluble in water. So the first property is solubility in water. So the second property, they are less dense than water. You see in the picture, right, a paper cup, not a paper cup exactly, a styrofoam or a thermocol cup, okay, being floating on water. Let me show you how it happens. I have a jar with me. Let me open the jar. I have put a thermocol. Can you see? See, I have put a thermocol in water. It is floating on water. I am trying to push it with a fork. See what happens? I am trying to push it. I have pushed it. It is down, right? If I leave it, it's going to come on top. Can you see? So hydrocarbons are less dense in water. Okay, they float on water. The third property is combustion. As I already mentioned, they burn in the presence of oxygen. They are readily burning, they are flammable. So, hydrocarbon plus oxygen, when they burn, they give out carbon dioxide and water. Okay, this is the third property of hydrocarbons. The fourth property, what are the states in which the hydrocarbon is present? There are three states of matter. What are they? Solids, liquids, and gases. Okay, for example, we will take water. Water is present in all the three states. For example, ice is a state of solid. When you pour ice and put it in the fridge, it becomes solid. Water which you drink or you find it in different vessels or the natural water bodies is in liquid state. The third one, the water vapor, is in gaseous state. So, how water is found in three states, similarly, there are different states in which hydrocarbons could be present. What do you see in the picture? Have you seen this picture before? This is a cobar gas plant where they use the cow dung to produce biofuel, or it is the biogas. It uses methane. Okay, biogas is using methane as its biofuel. Okay, so this is a biogas plant. So it could be present as gases. Hydrocarbons could be present as gases. Example, methane. Okay, the second state is liquids. Okay, what are the examples of hydrocarbons being present in liquid state? Will be benzene or hexane. They are all liquid state of hydrocarbons. The third one, they are waxes. As I already showed you, candle, right? This is a paraffin wax. The hydrocarbons are present in waxes. The example is paraffin wax. This paraffin wax is used in salons for the treatment, for cosmetic treatments. It is used for making crayons, for candles. So the fourth property is the state of hydrocarbons. Carbons are present in three states, which is the gaseous state, liquid state, and the waxes. Okay, that is the fourth property. Next, the final, the last one, the fifth property. What is the fifth property? It is called catenation. You see three structures, right? A, B, and C. They are marked as A, B, and C. So they are not single structures. Can you see connections between them? It has a ball like head which has connections. So these hydrocarbons, which is composed of hydrogen and carbon, are capable of forming chains where one compound or one hydrocarbon connects with others. Can you see the head? And there is connections. They are forming complex structures. It is not a simple structure. You don't term this as a simple structure, but it is complex. So see, A, B, and C are not the same. They are different structures. Okay, so catenation or chain forming is the last property of hydrocarbons. So see, A, B, and C are different structures, so they will have different names. Okay, they are found in different structures, they will have different names. So hydrocarbons are capable of forming chain structures which lead to complex substances. So the fifth property is catenation or chain formation. So the final topic. So I told you, right, hydrocarbons are made up of hydrogen and carbon. So what is prefix? Prefix is a name given before. Pre means before. So prefix is before. The small attachment. For example, let me give you a word. Healthy. Healthy is being strong. Okay. So what is the opposite of healthy? Unhealthy. So un is a prefix attached to healthy to make it a another word, to form another word naming unhealthy. So you understand what is prefix, right? So similarly, hydrocarbons have prefixes. The first few letters, one or two letters, which is attached to show the different number of carbons in it. So, okay, so there are 10 carbons. There could be 10 carbons. So the first one being meth, meth, eth, prop, but, pen, hex, hept, oct, non, and tech. How do you remember all these 10? So I will give you a small hint. We will remember it in a phrase. So what do monkeys eat? They eat bananas. So we're going to use this, to frame or to remember a simple sentence to remember the prefixes of hydrocarbons. First is monkey. M for monkey. Second, E stands for eats. What do monkeys eat? Third is P. So it is peeled or peeled bananas. Okay. So we finished fourth. Fifth one is pent. So we abbreviate pent using what do you say? Pent, pent. So pent is pudding. So monkeys eat peeled bananas, pudding, hex. We will remember X as X. X, is a short form for hexagon, which has six sides. Okay, hexagon has six sides. So monkeys eat peeled bananas, putting X on hundreds. Hept will abbreviate, or we'll put another word saying hundreds of nice ducks. So I repeat, monkeys eat peeled bananas, putting hex on hundreds of nice ducks. So that will give you a small, easy sentence to remember what are the prefixes of hydrocarbons depending upon the number of carbons present. Okay. So, what all did we learn today? We learned what are hydrocarbons, what are the five important properties of hydrocarbons, and we learned about the prefixes of hydrocarbons. So, I hope the class was very clear. Thank you, class.